So, friends, we are into operation research and simplex method. We are going to demonstrate the salient feature and the procedural aspect of simplex method through numerical example that we have been discussing in the previous lectures, and now it will be extended to demonstrate the complete. I think in previous lecture we had seen the procedural steps that are involved or algorithm that we, and now in this we will see them in a how numerically they are solved. There will be a comparison with the because if you want to demonstrate that the right optimization has reached, that means by a simple case you have to solve by graphical or the graphical methods or algebraic method, and whatever solution we get here, same solution should be given by simplex method also. Only difference is simplex method can handle complex problem which algebraic or graphical methods will not be able to solve. So, as we said, first step in simplex method was formulation of a table. So, we are probably you might feel that we are talking same thing more often, but it is required to get a clear idea. So, again the same wood and labor thing for the company which is manufacturing table and chair, and these are the resources 30 board feet and 20 board feet for table and chair, labor 510 for table chair, resources 300 board feet and 110 hours for labor, unit profit per table it is 6 and for chair it is 8. That is what we have, and then here is our problem formulation. We are revisiting here sort of, you can say, addressing the inequalities. How you remove the inequalities? Here it is very clear, 30x plus 20x, earlier it was less than or 300, now it is equal to 300. Why? Because we have introduced a variable slack variables SW, that is for wood, and this another slack variable S for labor, and we brought in remove the inequality. Once we have done that, then we got the maximization also. Equation got translated into 681 plus 8x2 plus 0 SW and 0 SL. That means virtually it remains same. This variables, slack variables have been assigned 0 figure. Now subject to what it subject to, 30x, again the same equation and plus 0 SL. Now here we have to take both the variable 0 SW, 0 SL. So it has no value here. Okay. Similarly, 0 SW has no value. So the equation remain the same as we had here, and this is what now the equation for 2 variable problem, now it got extended to 4 variable problem where x1, x2, SW, SL, they are more than 0, non-zero condition. Probably this formulation of the table is clear to all of you. Now we extend this thing and we work upon this problem in terms of basic variables and mixed non-variables actually, So what we have, if we have x1 and x2 0, if we have x1 table number, no chair, no table, no chair, no table, then what it will be, SW will be 300 and 110. Okay. If we have 0 and 11 value, so all these values we have put up, and we have and for the last 2 cases we do not have feasible solution, because 22 and this thing I think we'll discuss here why it is going. So how many corners are there? A, B, C, D, E, F. So now that means we are talking about the algebraic solution, but we will demonstrate through graphic thing also. So, as I mentioned, what is the basic variable and what is the non-basic variable, we will say, and what is corner. The basic, the variable chosen for solving algebraic formulation are called basic variables, variable mix. It is a basic variable mix. That means it is not single variable, there are two variables. So, what are the combination that we have taken to solve this problem? And what is non-basic variable? The fixed value variable are identified as not being in the basic variable mix, okay, are referred to as a non-basic variable. The non-basic variables are assigned the value of 0. Okay. Now, corner, the algebraic solution of the constraint equation with a non-basic variable set to 0 represent the corner. See, it is looking the algebraic solution of the constraint of equation which with a non-basic variable set to 0 represents a corner. Probably we will get that thing very. So, we have this table, you can see here by varying the values we got the in the same equation, and how we got these values in the equation, that we will know. Okay. Okay. So, here is the answer. What we filled in the table, if x1 and x2 is equal to 0, then what we have is SW is equal to 300 and SL is equal to 100, which is what it was there in the table. So, 300 and 110. Now, if we see that, and that is the figure for corner A, that is coordinate x1 0, x2 0 is a coordinate which is shown over here. Now, let us see, we evaluate the coordinate B. Coordinate B will, what will have? Coordinate x1 is equal to 0, coordinate x2 is equal to 0, okay, and SL is equal to 0. Okay. So, whatever the wood graph is there, the labor graph will be 0. So, what we have here is 30 into 20, 30 0 plus 20 x2, okay, and plus SW, and this is 0, that is SL is equal to 0, that is what we said, SL is equal to 0. So, x1 is 0, but x2 will have some value here, x2 will have variable, you know. So, we will not put 0 here, x2 is not 0. So, with this evaluation we will get SW is equal to 80 into ST, this one. So, x2 on x2 it will be 11 for this coordinate, and of course, for the first coordinate A the profit was 0. For the second corner the profit is 88. That means, if we operate at this point, profit will be 88. Okay. And x2 is equal to 11, as I said, x2 is equal to 11 we have evaluated. Okay. Now, for corner C, let us see this corner C, coordinate x2 is equal to 0, coordinate C means x2 is equal to 0, no coordinate, okay, and then SW is equal to 0 because the wood is touching over here. So, 0. These two coordinate if we take, then we get in the putting the value in the standard equation, and we will get x1 is equal to 10, okay, x1 is equal to 10, SL is equal to 60, okay, and then Z is equal to 60. So, for C we get a 60. So, this profit was more B, you know, and we have here. Now, corner D. Corner D is where? Corner D is here. So, corner D, SW is equal to 0 and SL is equal to 0, because we do not know these two value, but we know x1, x2 value. Okay. So, for coordinate 30 x1, 20 x2, 0, 0 and 300. So, 30 x1, 20 x2, and again here x1, x2 is there. So, 5 x1, 10 x2 is equal to 110. So, x1 4, x1 4, x2 9, and Z is equal to 96. What it shows? This is the optimum solution for this problem, and this is very important to note. And Z is the traffic, we got profit, we got here 96. So, this is the optimum solution. That means, we got one benchmark figure using the traditional algebraic equation method using the graphic solution, that this is the profit that is available. Okay. So here what we have seen, a graphical equation matching with the algebraic equation. We are trying to infer values from here, and we got this solution. Please remember this solution. And if we want to prove or we want to check the simplex method, which is very complicated, but what solution we receive at the end of it, we want to see this solution should be available. So so we said that why we should use simplex. Most of the problems in real life involves very high number of corners, and a graphical as well as algebraic modeling methods become either prohibitive or involve high level of complexity. Second, each corner solution might involve complex algebraic length. See, we have seen how much evaluation we have to perform with only 2 variable 2 equation problem. For example, example of 10 variable constraint, I think we have said this 10 equations, it will be almost like 2 lakh or around that kind of corners that will be available. Simplex problem, particularly on computerized platform, provide an elegant framework for linear programming solution for a real time situation. So now we saw that there is a need to and of course the scenario in the market shows that simplex is being used left and right for optimization of resources. Okay, so let us get into the simplex method. Again, the first step in simplex method is to develop a tableau. Now x1, x2, SW slack variable SL 1 0, we have got 1 we have kept here, 1 we have kept here, 0 0, and this 300 solution. Initially the solution is 300. And then 6 8 are unit profit on table and on chair. So the slack variable is 5 10, that means 5 10 0 1, 5 10 0 1 and 32. So this is the table we have formulated. Now we know that these are non-negative number x1, x2, SW, SL, that is slack variable wood and labor. They are non-zero, non-negative condition. Reflecting the information on table, we have reflected the information on the table. The row in the table indicates basic variable mix. Row indicate basic variable mix for the corner point to be evaluated. So the corner point to be evaluated. For all the resources remaining unused, again we have done it earlier. So if x1 and x2 is equal to 0, then SW is equal to 300. Okay, and if x1 and x2 is equal to 0, then SL will be is equal to 110. So this evaluation also we have done. So objective of first step was to formulate the table, and that we have done. Now the step 2 is find the sacrifice and improvement row, like we did earlier. So initially these rows were sacrifice row, as per the rule, the value in the sacrifice row indicate what will be the loss in the, I think we are repeating here, value in the improvement row indicated what is the gain in profit. Okay. So improvement row 6800, and then losses as present is 0 because we have not done any change, and current profit is 0. So this is the comparison and unit profits at this side, which will be varying thing, which will validate whether we have whether we have got optimum solution. So these are operating unit profits actually, now corner decision, the sacrifice and the improvement row help in deciding whether we have reached the optimization. The original coefficient highlights in the simplex table, whatever we have marked, these are coefficients. W are called exchange coefficient. They indicate how many units of the variable listed on left side must be given up to achieve a unit increase in variable listed on top. Unit variable this listed on top. How much we should give in to increase this value for this variable which are written on the top. The 30 indicate 30 board foot of wood used for this thing, and table for chair it is 20 board feet and 5 hours for labor and all that. So these are the coefficient, and now these are solution. These are the unit profit. At this side, left side, it is 0 0 because it is a dynamic part, and this is a static part per feet per profit per unit profit for table and chair. which is reflected here also. Now let us see how we go about doing that. Now how to compute the sacrifice row. Okay, a very systematic procedure has been given. Sacrifice row can be computed by value for the sacrifice row determined as follow. Unit sacrifice is equal to unit profit column. Unit profit column में value, what is the value? 0. Exchange coefficient column 30. So this is the first value in the sacrifice row. First value, how to fill up? This is the procedure. The first profit column 0 value, x1 column, because the value is going in x1 column, 30 and 5 are there. So if we get this and if we sum up, this is a plus sign, add this thing will get 0. So that 0 value goes into the, so here sacrifice row we get the 0 value, but this is okay. So similarly, now let us see for the next sacrifice row. Again, what value will come? Again it is 0 0 0 0. So you saw that 0 value is there in the sacrifice row. Okay. Other sacrifice row value also calculated to be 0. So eventually what happens is all the values remain 0 in the table. This just you bear in your mind. Now we call the improvement row. Improvement row values are estimated by subtracting each value in the estimated sacrifice row value, previous slide row, and so unit improvement is unit profit. Okay. So unit profit is what? 6 for column x1. Okay. And unit sacrifice is 0. So that is the value 6 which will come in the improvement row. So that we'll see in the next slide. Then third step is apply the entry criteria. Applying the entry criteria, that means we are identifying the variable top row or side row to see which are the variable which will give us entry and exit condition. The entering variable is current non-basic variable, that will most improve the objective if it is increased from 0. Definition. Now entering variable as it will be enter the basic mix when next W to evaluate the new corner. For maximization of the determine the entering variable by finding the largest value in the improvement row. The largest value in the improvement row will be giving us the entry variable. Element 8 is the highest value in the improvement row. Therefore, row x2 can increase the profit by 8 per chair. Identify the variable, and now we will see this operation in the table. Okay. 8 is the value that give us maximum profit. So this becomes the x2 becomes the entry variable. Okay. And SL becomes the exit variable. How we will see that? The exit variable is the variable that will exit when the new W is constructed. Okay. The exiting variable is evaluated by calculating the exchange ratio for each variable. So this is the exchange ratio we are estimating for 300 divided, because for this row it is the 20 is the figure identified by this particular column. So 300 divided by 20, that is solution space, divided by 20 will give us 15, and this 110 solution divided by 10, that is pivotal element, will give us 11. So we got the exchange ratio here. Now what is done? The existing variable you learned by calculating the exchange ratio for each variable. Okay. So significance of exchange variable is that it informs us how many tables and chairs can be manufactured by using all the resources that is available to us. The exchange ratio is found by dividing the that we have done this one. So 300 by 20 and 15, and this one thereby 110, 11 we have. 15 chairs cannot be manufactured. We got 15 chairs here. You see, 15 chairs cannot be manufactured, cannot be resources, because it will cross our resources time actually. So what is left with is 11 chairs. Okay. So 11 chairs is the answer. The limiting resource, so that means SL will be identified in this. So here it is the exit variable. This will be the exit variable, and now this will give us the new corner. New corner means how the number 10, x to 10, number 10 x to SL is the pivotal element. Pivotal element means it is this way you see and this way you see, which has been identified by the number 11, and we got the new corner. And once we have this this element, construct the new. Now one table job is over. We have replaced the variable. The current profit was 0 because we didn't find any optimum, so the original table remains here. Now we have to find out the next table. Next table, what you found out the x2 row here, and 10 is the element. We will evaluate this particular row. Okay, we will evaluate this particular row. So what we do, fill in the new x2 row, divide all the variables by SL by the pivotal element 10. So 5 by 10, okay, 5 by 10, 10 by 10, 0 by 10 is 0, and 1 by 10. So we got this value, this new value has come, okay, and now the variable itself got replaced, basic mix. This is x2 now, and the element 8 has come here. We discussed how that is unit profit has increased with 8. That x2 variable, that element has come here now. Now fill in the new SW. What is new SW? How you will fill? This you will fill by multiplying the 0.5 into the 0.5 into 20, 1 into 20. So 20. So the 20, this element, because we have to fill up this row, this variable becomes the part 20 divided by 0.5, 20 divided by 0.5, then 20 into 20 into 0.5 is equal to 10, and 30 minus 10, 30 is one variable, first variable. So 30 minus 10 is equal to 20. So the 20 has come here. Similarly, we will fill up other things also. So this formulation I have explained for each element in the row for you to make it clear. So this row we have completed, SW row we have completed, x2 now you see it has come here because it was coming in the this thing entry variable. Now we got this new one. Now we have to work upon this table. This was the table, and now our this solution point, notably our solution point also has improved, because same procedure 20 into 11, 220, 300 minus 220 is equal to 80, and 11 was there earlier. So the whole table got transformed. It is called the second table. Now for getting to the next point, the second table, now our pivotal point is become 20, okay, by applying the same procedure. Fifth, construct the table, identify the pivotal point and all, and we have found that now our exchange ratio for this time also is 80 upon 24 and 22, and again you fill up the same thing. Now you see the improvement row and sacrifice row also have changed. The procedure remains the same. You follow the procedure, make the third table, and you will find the optimum point. What is the optimum point? 4 table, solution point is 4, 9, that is table for 9 chairs, and then you have 96 is the profit. I have not repeated this step because we have done it earlier in the procedure, and probably once you do it, you will get it. There are no positive numbers in the new improvement row. You see, there is no positive number, either 0 or negative. So this is an indication that we have reached up the optimum solution. Thus solution cannot be improved, and therefore it is considered optimum, that is the profit is maximum, that is 96 for x1 4, x2 9, of course z is 96. So this is how a complete procedure for simplex method has been demonstrated. If you find it little confused, please solve the one problem and you will understand for yourself. In fact, you can solve any algebraic equation type of question and you solve by simplex method, you will arrive at it is very easy, though it looks very complicated. So with this we complete the third lecture of operation research and simplex method has been demonstrated. Thank you.